Today we are going to talk about special relativity. It explains how space and time behaves when object moves at extremely high speed, especially close to the speed of light. Sorry. Einstein two postulates are first one is the of physics law of physics are the same for all observers moving at a constant speed. And the second postulate is the speed of light in a vacuum is constant for every observer. Consequences of special relativity. There is a time dilation and there is a length dilation. So first we will talk about what is time dilation. Moving clock runs slower than the stationary clock. This is called the time dilation. An astronaut travels near the speed of light. So the formula that we are going to use for time dilation, that is t dash t t dash is equal to t over 1 over 1 under root of 1 minus v square over c square. So what is t? T is the proper time that is measured using moving clock. T dash is the time measured by the stationary object or clock. V is the speed that it is moving and c is the speed of light. As speed increases, time slows down. Now we are going to do first example of that. With examples, you can understand it quite well. Okay, a spaceship measures measures a journey lasting lasting 2 seconds, and it it travels at 0.8 c, that is speed of light. Find the find the time measured on on earth. So what we are going to we are going to use the formula that is simply t dash is equal to e over 1 minus v square over c square. So here what is t? T is 2 seconds, so that is 2 seconds divided by 1 minus what is v is 0.8 c divided by c. So we will cancel that out. So that would be 1 minus 0.8 is 0.2. Under root of 0.2 is what? Under root of 0.2 is something like 2 divided by 0.6, and that will give us 3.33 seconds. That is for time dilation. We will do one more example, that is example 2. A moving clock a moving clock measures 5 seconds measures 5 seconds. The object travels at 0.6 c. So find the stationary observer. Again, we are going to do t dash is equal to 5 seconds divided by 1 minus 0.6 square, that is 0.6 square, that is equal to 5 divided by 1 minus 0.36, and that is equal to 5 divided by 0.8. So time dilation is 6.25 seconds. Now we are going to talk about length dilation. That is simply, the formula for that is simply L dash is equal to L into 1 minus V square over C square. So L is length measured at rest, and L dash is length measured at motion. What that would be? So I will do one example for that. So that example is a spacecraft. A spacecraft is 120 meters long at rest. It moves at 0.8 c. Find its observed length. Observed length. So simply what we are going to do is put the values. So under root, first I will solve inside the under root, that is 1 minus 0.64, that is equal to 0.6, and then I will just put that value into the formula. So that is L dash is equal to, what is length? Length is 120, and that is 0.6, and that will give me 72 meters. That's all about it, and I will see you in the next class.